that an atom has a compact center called the nucleus. The nucleus contains two types of particles: protons, which have a positive electric charge, and neutrons, which have no electric charge. Small charged particles called electrons exist outside of the nucleus. Electrons have a negative charge and they are attracted to the positively charged protons. The electrons move in high-speed orbits around the nucleus, held close to the nucleus by the strong force of attraction from the protons.
An atom, a system of electrons circulating around a heavy nucleus at almost inconceivable speeds. In order to explain the principles that are concerned in this story, let's assume that we can stop the action within the atom by a positive charge in the nucleus equal to the total negative charge of the electrons. We have been concerned so far with the electrons within individual atoms. Now let's see what happens when two or more neutral atoms come together. The outside electrons will no longer move exclusively within their original atoms, but will circulate about both atoms at once. And if we bring many such atoms close together, as in a piece of metal, then many electrons detach themselves from their original atoms and move freely throughout the metal, charged.
In most solid materials, the atoms and their electrons just sit there and don't really move around. But in metals, like copper, the electrons have the ability to move around. The positive nuclei stay in the same place, preserving the structure of the metal, but the electrons can drift around from atom to atom, so move other electrons from atom to atom. For example, let's say you have a wire that's only one atom thick. And just so you know, I'm massively oversimplifying things here by showing you only one electron per atom. Then let's say that you force the first electron in line to jump to the second atom in line. The electrons will all push each other around at the same time. Even though each electron is only jumping a tiny distance, this overall flow happens close to the speed of light. And that's basically what the flow of electricity is. When electrons are flowing through something, you can say that electric current is flowing. Over here, the negative terminal of the battery is pushing the negative electrons away, and those electrons are pushing other electrons away. And this keeps happening throughout the circuit, allowing energy to be transferred from the battery to the light. Now, they're very handy for when you don't want to die in a terrible fire.
A battery is a chemical device capable of converting stored chemical energy into electrical energy. The chemistry of a battery creates a force that moves electrons out of the metal plate on the negative end and attracts them to the metal bump on the positive end. Electrons will start to move from minus to plus if the right kind of material is connected to the battery. Copper is the most common metal used in wires. In this animation, a conductor is connected to each terminal of a battery. Electrons start to move, traveling from the negative terminal towards the positive terminal. This is electricity. The electrons actually move from atom to atom as they travel through the conductor. Do you notice the letter V on the side of a battery? This represents volts. Volts, or voltage, is a measure of the force moving the electrons. A AA battery is usually 1.5 volts. This is a low voltage, and that is why it is safe to handle a AA battery. Higher voltages are dangerous. Never experiment with anything that plugs into a wall outlet. Wall outlet voltages range from 120 volts to 240 volts. Extremely dangerous. Here is an example of a low voltage battery being used to create some light. Connecting a light bulb to this battery, we have created a circuit, a path for electrons to travel on. Our light bulb does two things. It introduces some resistance into the circuit, reducing the flow of electrons so that the copper wires won't get hot, and it converts electrical energy into light energy.
Today, the majority of America's electricity comes from thermal power plants. Fuels like coal, natural gas, biomass, and uranium are used to heat water until it produces steam, which powers a turbine and generates electricity. That steam turns propeller-like blades around a rotor inside the turbine. This turning rotor connects to a main shaft which spins magnets with a coil inside a generator. It's the generator inside a turbine that converts mechanical energy into electric energy and creates electricity. Steam is an efficient method of producing electricity because the water can be recycled and reused as it changes back and forth between liquid and gaseous states.
Over half of FirstEnergy's electricity is produced by using coal, compared to about 60% nationwide. Let's see how electricity is generated from coal by taking a virtual tour of a coal-fired power plant, similar to those operated by FirstEnergy. This plant has 3 generating units that produce more than 2,000 megawatts of electricity. At full capacity, this one power plant can produce enough electricity to supply the needs of 1.5 million homes and businesses. Generating electricity requires a fuel source. At this plant, the fuel source is coal, which arrives mainly by a barge but also by rail and truck. Each barge delivers 1,500 tons of coal, enough to keep the plant running for a couple of hours. The plant uses about 21,000 tons of coal each day, so large fans add warm air to the powdery coal and blow it into the boiler. The boiler has miles of tubes filled with high-quality water. Once inside the boiler, the coal ignites, releasing energy and generating intense heat that changes the water inside the tubes to hot, dry steam. High-pressure steam, now 1,000 degrees Fahrenheit at 3,500 pounds per square inch, is piped from the boiler to the first in a series of turbines. Here, in this process, the steam turns the series of turbines 3,600 revolutions per minute, providing power to the generator, the last in the series of machines. The generator continuously creates an electrical charge of 34,481 amps at 18,000 volts of electricity. From here, the electricity leaves the plant and begins its journey to customers. Let's take a look at how the electricity is delivered to our homes and businesses. Transformers located just outside the plant boost the power from 18,000 volts to 345,000 volts, so it can travel long distances over transmission lines to where it is needed.
AC power that we could not get from the old DC system.
When electricity leaves the power plant, it is in its most powerful form, or as high as 765,000 volts. To compare, when it gets to your wall outlet, it is just 120 or 240 volts. From the power plant, transmission lines carry electricity long distances from city to city or from state to state. And these lines are held up and linked together by transmission towers, which transmission lines are actually bare aluminum or copper wires which are conductors for the electricity. Before electricity can travel from the transmission system and be delivered to your home, it has to make a stop at a substation like this. You've probably driven by a substation and not even realized what it is or what it does. A substation is enclosed by fencing for safety and houses the equipment that changes the electricity from one level to another. The electricity coming from the transmission line runs through a substation transformer, which transforms the electricity or steps it down to a lower level, reducing it from as much as 765,000 volts to less than 39,000 volts. Equipment that looks like a can. It is called a transformer. It takes the electricity from the wires at the top of the pole and steps it down to the lower level needed for a home or a business. Remember, wires can either be on a pole or buried underground. Electricity actually passes into your house through the meter. A meter is a box usually found on the side of your home and measures the amount of electricity that you use. It is owned by the power company. From the meter, the wires and electricity actually enter your home or building through a service panel that contains either circuit breakers or fuses.